Example 7. A bacterial population y after x days can be represented by an exponential function whose graph passes through 0, 100, and 1, 200. Part A, write a function that represents the population. Now, just like what we just did, a key word here is they tell you that it can be represented by an exponential function. Okay, and then this one, instead of having a graph, only gives us 2 points, but we can still start the same way and look at a table. So on our table, x and y, I've got 0, 100, and I have 1, 200, which if we know this is an exponential function, they told us that, this is plenty of information. So just like before, we go from 0 to 1, and then the question becomes, well, what's the ratio, or what do we multiply by to get from 100 to 200? So we're going to multiply by 2, so I know that the common ratio is 2. So in our function y equals a times b to the x power, we know that b is going to be 2. And we discussed that a is your y-intercept, which is sitting right here. So keep in mind when x is 0, that gives you your y-intercept. So our function is going to be y equals 100, the y-intercept, times 2, our common ratio, to the power of x. Now, find the population after 6 days. Well, we're going to substitute in 6. Y equals 100 times 2 to the power of 6, which is going to give us 6,400. And this is, once again, bacteria after 6 days. Now, part C. Does this bacterial population grow faster than the bacterial population in example 6? Explain. Well, if I'm looking at day 6, this population has 6,400 bacteria. I'm going to flip back for a minute, and I know that after day 5, this bacterial population has a population of 3,072. Well, what if I were to go to day 6 here? I mean, we could just, this one's multiplying by 4, multiply by 4, multiply by 4, multiply by 4, multiply by 4, which got us 3,072. If I multiply by 4 again, that's going to give me 12,288. That's huge. Now, pretty much what I'm answering here is this one's multiply by 4, multiply by 4, multiply by 4, multiply by 4. This one, multiply by 2, multiply by 2, multiply by 2. So really, I don't care about the numbers. If they want to know which one is growing faster, well, which one's going to grow faster? One that's multiplying by 2 or one that's multiplying by 4? Okay, the one that's going to grow faster is the one that's multiplying by 4. So does this bacterial population grow faster than the other one? No. Okay, example 6 grows faster because the common ratio is larger. Okay, so we're talking about 4 versus 2. The common ratio of 4 is going to have something grow a lot faster than a common ratio of 2 because you're only multiplying by 2 versus multiplying by 4.